there's your first question. Second question. Okay, so we got two questions. Right, we are simplifying or reducing, and then you're listing the values that x can't be. Right, what would make it undefined? You look for the denominator factors that would make it real. Yeah. Yes. Yes, except that that's what happens when you change the order. Yeah, but that is correct. You should change the order. That is right. Okay. Yep, it is. And then, how do you divide by a fraction? Well, you multiply set up. Why is there a negative? Because this is equal to this. Right? Yeah. And also, why is there it's not, that's a square. Sorry. No, only the thing that you are actually dividing. If I put grouping symbols, and you have to split everything like this, so only flip the one. Excuse you. Hey kids. So is that yes. No, this isn't versus the world. This is his funniest power. Okay, this one's called a complex fraction, which means it's a fraction in a fraction. Okay? There are grouping symbols that are implied. Right? When you have a fraction, you imply that there's parentheses around the top and parentheses around the bottom. And so I'm going to write this in a horizontal format instead. Okay, so now as I do this, I notice that this piece right here, it's not in standard form. The x doesn't come first. And so I'm going to rewrite it in standard form. Okay. Now, as I do this, I'm going to start factoring. Minus 3x plus 1. Okay. Divide by this, which is really multiply by the reciprocal. I guess we'll do it one more step. Okay. Okay, divide by x plus 1, x minus 3. Now, the only piece that hasn't been factored yet is the top left piece. Okay, so this is going to give me negative. Okay, so difference of squares. Multiply. Okay, and then reduce. Nothing else cancels out, so negative. Now, you do not have to multiply out your final answers. You can just leave them in factored form, because then automatically you can see that there's no common factors to be crossed out.
What about x squared? Oh, yeah, there's negative x squared too.
Yeah. Question. Right, on just how this simplified. Here's the simplified answer. Okay. No common factors other than 1. What are the restrictions? Okay, so I like to use a pencil for this. There it is. What's going to make my denominator 0? Now I'm going to go back to the original question, okay? Right here. This is the original question. I just put it in a horizontal format. I'm going to circle all the denominators. Okay, those two pieces are the denominators in the original question. I don't like the vertical format. It's a little bit too tricky. I prefer the horizontal format. Okay, so what values can't x be? 3 and negative 1. Makes sense. Look at the factors of the denominator. Okay, and then here, x can't be 3. I know that I wrote the number twice. That's fine. We're just going to list them when we're done. And then I have to look at the next step, because I had a divide here, and so I actually had a reciprocal. Look at that. I had a new denominator show up right here. Okay, see that divide? I know that that is going to turn into the denominator here. And so I have to also include negative 1. It's because of the division sign. The division is going to make both of those pieces denominators at one point in the question. And so you've got to be sure to look at both the top and the bottom of that divided fraction. And so then I look at it, and it looks like I actually only have 2 numbers, right? 2 numbers. Did I miss any other denominators? No. And so you would just list all of the different, you don't have to list them twice. You just list the number when it shows up. Okay, let's do the second question. Right, notice that this is quadratic form. Now the first one here is over 1. Okay, there's no rewriting. All of these have the x's that come first, so they're in the right order. And you're going to multiply. I guess I could, yeah, we can change it. Okay. It's a little tricky. How do you multiply with 2 letters? Well, if you could just ignore the y squared for a second, how does that factor? Multiply to 4, add to 4. It's the same thing with the y's. You're still going to multiply. How do I multiply and add to 4? 2 and 2. Okay. How do you multiply to 4y squared? 2y times 2y. How do you multiply to x squared? X times x. Both pluses. I would suggest not using exponents until you get to the end for your answer. It's easier to see which ones cross out without the exponents. Okay. Notice that this is the only one that I'm flipping right here. That's it. That's the only one that's going to flip. You're only dividing by one fraction, the middle fraction. The other one is multiplying. Okay, multiply to x squared. Multiply to 10, add to 7. Okay, multiply to x squared. Multiply to 5y squared, add to 6. And you look for common factors. Cross them off. 2y, 2y, 5y, 5y, xy, xy, xy. All gone. 1. Not 0, 1. If I were to list the restrictions, how would I do it? Now I want x can't equal. Okay, I know there's 2 letters there. I just want to know what x can't equal. I suggest you circle the pieces of the fraction that you're looking for. Okay, right? I'm looking for the denominators. Notice if I have a reciprocal, you have to circle both the top and the bottom. If you have to flip something, you need both the top and the bottom of that. It's a lot easier if you circle the factors that you're looking at. So what can't x be? Well, there's no x's here. So you don't get anything. What are the zeros of each of the factors you circled? So this one says negative 2y, check, check. Negative y, check. Negative 5y, negative y. All you did is you solved for the zeros of the factors. Okay? Look at this. X plus 2y equals 0. That's how you find a restriction. You take the factor equal to 0, and I just said, what can't x be? Yeah, it means you're just going to have to leave it in terms of y, because it's not actually a number. What would I ask you on a quiz? I would ask you this one with x's only. Okay, I wouldn't ask for the restrictions with x's and y's, but you could do it. Okay, lesson 5. We are starting add and subtract. Okay. Fractions. Least common denominator, and we're going to use LCD for an abbreviation. And this definition,
is it TFT or IPF?
It's actually the least common multiple, right? It's a different name. Least common denominator is the same thing as your least common multiple.
Nice.
Okay. Great. Okay. Now, how do you define that? Consist is exactly same number of each factor in each denominator. The tricky part with common denominators is when you start repeating factors. Okay? So we're going to do 3 really quick examples with no factoring, and then we'll do maybe 1 or 2 with factoring. So the first example, if I say, I'm going to do capital letters. Okay. A over B plus C over D. Now, assuming that A, B, C, D, those are all factors, okay, or they're monomial terms. How would I add them? Right, common denominator. Okay, so I'm going to underline, okay, B, and I'll underline D in a different color. So I have a blue factor and a green factor. I need exactly the same factors in each denominator. So when I list out my least common denominator, I look at all the different colors. I only have 2 colors, so I only need 2 factors. So that's B, D. That's the common denominator. Okay. What's missing in the first fraction in the denominator? Green is missing, right? Green is missing in the denominator. Okay, so how do I write this? Well, A for B. Leave a little bit of space. Okay. Green factor is missing in the first fraction. Blue factors missing in the second fraction. What does that give you? Well, it gives me AD plus CB over that's it. Okay, we're writing letters because it's much faster than trying to factor and do common denominators. All we're looking at is how do I get from here to the common denominator in one fraction. Would I prefer you to be able to go straight from here to here? Yes. Okay. We don't need to keep copying the problems over. It's a lot to copy. Would I make a note to myself like, okay, multiply D and multiply B? Yeah, I would prefer like a little shorthand on how you're going to get your common denominator and then go straight to the combined fraction. Okay, so our second example, right? Letters only, so it's faster to write. A over B, C, D plus E over B, F. What would your least common denominator be?
B squared CDF? No.
Oh, wait. Least is the key. That is a common denominator, but that's not going to be the best. It's not going to be the least. Okay, so think about it. Okay. I'm going to underline my factors. And, okay, so I have a B and a B, but they're both green because they're the same factor. Okay? Now, I'm going to underline the next one. C. Okay, there's no C over there. It's fine. Okay, I'm going to underline D. Okay? And now I'm going to look for, I guess I'll have to switch to highlighter, okay? Okay. How many different factors do you have? Green, blue, red, yellow. 4. That's it. 4 factors. When you first learn fractions, you just swap the denominators. Well, I only need you to swap the ones that aren't the same. B is the same. You're going to swap the ones that are not the same. So F is going to come over here, and C and D is going to come over here. So what's our common denominator? B is common. Great. C, D, B is already there. F. I have 4 different factors. That's my common denominator. Don't overdo it. I don't need B squared. B only shows up once. Only have it show up once. Okay, so what would the combined fraction be? Well, B, C, D, F. There's my common denominator. I got a plus. Okay, you're only swapping the parts that are not the same. AF, yep, so we got AF. Okay, so over here, I got to multiply by F because that's the part that's missing. What do I have to do over here? CD. Only CD. It's what am I missing from the common denominator? C, D, E. Alphabetical order is an easy way to write it. Okay. Right. Third one with letters. Yes.
So for the first thing, why do you multiply by F and not B? Because F in the common denominator.
Okay, so look at the colors. I don't need to multiply by B. It's already common. I only need to multiply what's not common. I don't need B. It's already common. It's already the same. I only need to multiply the parts that are different from the denominators. You would get a common denominator. It would not be the least common denominator. Now, when I'm looking at letters, you're like, it's not so hard. Why can't I just write B squared? You can. But as soon as I turn this into a polynomial, you like your degree to stay as low as possible, so you do not want to multiply by anything extra. Okay, so we're going to look at, let's do our last example, and then hopefully that'll answer your question. This time I'm going to write B squared. Okay, right? I'm going to up the degree here. And why not? Let's put a minus in. E, B, F. Okay. All right, what is my least common denominator going to be? And what is the combined fraction going to be? Okay, how many factors do you have in the first denominator? How many total factors? There's 3. B, B, and C. I actually have 3 factors here. B, B, and C. I know it's repeated, but you have to consider that there are 3 factors. Of the first one, and then of the second one, you have B and F. You got to look at them separately. I have B, B, and C, and then here I have B and F. Which ones are different? Which ones are common? B is common. B is common. Okay? B is common. I got that. So let me give that a green color. Okay? I've already got the B. You're going to swap what's different. So what's going to go in the first fraction? F. What's going to go in the second fraction? BC. That's it. You only swap the parts that are different. And so when I look at my common denominator, it's B, BC, F. B is common. That's where this one comes in. Now I have to look at what was different. B, C, F. Notice that my common denominator is just B squared CF. Look at what happens when I multiply the F. I get B squared CF. Oh, yeah, you're supposed to get the common denominator. What happens when I multiply the BC over here? B squared CF. They should multiply to the same quantity when you figure out what was missing or when you swap the factors that were different. Okay, so I get AF minus BCE over Notice that I boxed the answer. I'm not crossing anything out from there.
You don't cross it out.
Nope, we're just leaving it. Okay, let's do an example with some actual polynomials in there. Okay, I think I can make it fit, maybe. All right, I'm going to turn the page because I don't have a lot of room. And I write kind of big. Okay, I did skip an example for you, so hopefully we're aiming for just 2 more. Hopefully. Okay, number 4. 3 over x squared plus x minus 2 over x squared minus 1. Whoop. There we go. Plus 3 over x. I suggest leaving some space between them so that you don't have to keep rewriting the problem. First step, if we're going to figure out what factors we have, we're going to need to factor the denominators. Now, I'm not going to rewrite the problem. I'm just going to factor it right underneath the existing denominators. Okay. And you can just go 2 at a time. Right? I know there's 3 fractions up there. Just go 2 at a time. Make sure that you get the same denominator for every fraction that's up there. Okay. I'm just going to go left to right. I'm going to start at the first factor. X. Where is x? Okay. X plus 1. X minus 1. I'm looking across all of the denominators. I only have 3 factors that are different.
So you include in every single underneath?
Yeah. So I'm looking across all of them. And I'm just going, so I write my first factor down. Okay. Great. I don't see it, right? I see it here, but it's common. Okay, x plus 1. Okay, it's common. X minus 1. Notice that I've already looked at x plus 1 and x. You don't write it down twice. Okay, so what do you need to swap? Question? Okay, all right. What do you need to swap?
X and X.
Okay, let's compare. What needs to go where?
X needs to go on the second one.
I need x here. Okay. What needs to go in the first fraction?
X minus 1.
X minus 1. What needs to go in the last fraction? You swap the parts that are different, or the parts that are missing from the common denominator. Okay, let's write it as one fraction. 3x minus 1 minus 2 times x plus all over. Now this is going to be pretty helpful. You can, right, as long as you've told me what the least common denominator is, you can go ahead and write LCD. It's faster. Okay, let's put our numerator together. Notice there's a lot of adding, subtracting, and common terms we have to deal with.
You put both x plus 1 and x minus 1 on the x.
Where?
Over there.
I do, because look, it's missing both. Right? If you compare to both, you're swapping over the ones that are missing from both of the other fractions. Okay, so x squared minus 1, right? Pick two at a time. So what do we get? Right? Like terms. Okay. 3x squared plus x minus 6. Okay, once I finally get to the answer, then I will copy back in my least common denominator. Oh, x can't be 0, -1, and 1. Notice they come from the least common denominator, all the factors of the denominator. Those are your restrictions.
Which one is that? The blue?
Right here.
Oh, okay.
Okay. I'm thinking. Okay, here you go. I want you to try this one, and then we'll stop and we'll do your worksheet 12. Five over 6x squared plus x over 4x squared minus 12x. Okay. Try that one.
So is 6x squared one factor, or is it?
I'd consider it a 6 and an x squared.
Alright.
That's what I would consider it.
So there's three factors because the x squared is 2x.
The x squared is x and x.
Back there for both. Okay, so then does that cancel out the two other x's over?
Well, you gotta factor this not, right? You gotta factor first. Right? Factor it first so that you can swap the parts that are not already common. I suggest using your number skills with the 6 and the 4. Right? When using the really common denominator. Okay, what's not common?
Yeah, just do.
So I say common x.
Why would I look at it?
Yeah, okay, well that's x. I see all common x. I see 6 and 4. I see a common 2. Which means this is missing a 2 and this is missing a 3. Right, what's the least common multiple of 6 and 4? 12 is the least common multiple.
It would just be gray. Show this man.
No, I put it in the desk. Send it to the bench.
This comes
Okay, you're looking to swap only the parts that are not common. Well, there's a common x.
Well, we're gonna retake right now.
right? But look at your number though, 6 and 4. Okay, that's like your middle school fractions. What's the common denominator between 6 and 4? Least. 12. 12. Okay, I taught you how to do it with polynomials. You already know how to do it with numbers. Okay, well look at this. 4 is 2 and 2 and 6 is 2 and 3. They have a common 2. You're only multiplying the part that is not common.
Oh, so we can split this up.
Yeah, if you want, but really, just look at your 6 and 4 and be like, what's my least common? 6, 12, right? So with numbers, I suggest you do whatever you usually do with numbers, and just look at them. Okay? It's harder to look at a polynomial like out loud other common, right? I can't count multiples of polynomials. I have to break it up into factors. I can count multiples in numbers, so count multiples in numbers.
From anywhere in the school, because I'll back this school way.
Okay, least common denominator. I'm going to do a little bit of highlighting. So I get this. That's the only part that's common. X and X. That's the only part that I see as common. Now, your numbers, they're a little tricky. Okay, 6 and 4. Guys, the number part, that's where your math comes in. What's my least common denominator between 6 and 4, or my least common multiple? It's 12. It's 12. Not 24, 12. Okay. X is already common, and now I'm going to swap the parts that are different, which means, okay, I'm going to multiply a 2 here, and what's different? The x minus 3 is different. Okay, what am I going to multiply here? The 3 is going to get me to 12, okay? And look at that. This x is different, right? I underlined the common part, and I'm swapping the stuff that is different. Now, I circled the numbers because you're going to have to look at them and pick the least common multiple between your numbers. And I think that's it. Okay, so my least common denominator is 12 x minus 3, or 12x squared x minus 3. Okay, let's see what we get here. Five times 2 x minus 3 plus x times 3x all over. Now I'm going to check. How do you check your work? Make sure you got the right common denominator. Actually multiply these things together. 12 x squared x minus 3. 12 x squared x minus 3. Yeah. When you multiply your denominators together, you should actually get the least common denominator. Okay, so we get 10x minus 30 plus 3x squared. Yeah, okay. Over the least common denominator. You should put it in standard form. And so my answer, I should write it. (12x squared x minus 3). You could try and reduce, but I noticed that that numerator doesn't factor. Right? I kind of already checked, multiply to negative 90 and add to 10. I don't think I can get anything that works.
Why do you use 2 and 3?
How do you get to 12 from 6?
I'll multiply by 2.
How do you get to 12 from 4? By 3. Okay. All right. Go ahead and open up your worksheet 12. Okay. I suggest that you work together. All right. There's 12 questions. I suggest you at least do one from every row. right? I would go one from every row. Worksheet 12 is in your packet. I would suggest you go one from every row because there's different types of problems. And we'll go from there. Okay. I would start with one from every row. Yep.
Yeah. Smoking some weed in a hot pot? What? Smoking on trash cans.
I'll fix that in a minute.
Hey kid. Oh, what did you do? Almost time to stop. Your mommy's How do you feel?